Here I have a problem involving two functions, and the question is really asking us to find the inverse functions for both fx and gx. We can see here that fx is given with a domain, and its function is log e x plus 1, and gx is also given with a restricted domain, and its function is x squared plus 2x. What I want to do is break up the problem into two parts. So I want to deal with fx and gx separately. So we'll start by having a look at fx. So what I'm going to say is that fx is -1, or the domain is -1 to infinity for all real numbers, fx equaling log e x plus 1. And what I want to do here is I just want to be able to do a rough sketch of what this graph would look like. Now, because we're dealing with a log e x plus 1, we're going to have an asymptote running down at x equals -1. If I have a look at another part of this graph here, it will have an x and y intercept at 0, and because it's a log, it will take on that kind of shape. So the graph is actually really handy for us to use when we want to see what the inverse is going to look like, in particular when we have a restricted domain, because it actually gives us our range. Now, if I break this up and I'm having a look at the inverse function, what I'm really doing with my inverse function is I'm swapping the independent and the dependent variables, x and y, and then resolving them so that it is in terms of y. So if I take this section of the function and I'm just going to rewrite it as x equals log e y plus 1, and I'm going to resolve this with respect to y. So I get ex equals y plus 1 and y equals ex minus 1. Therefore, f dash x, f the inverse of x, is given as fx minus 1. And what I might do is I might also do just a rough sketch of what this might look like. Now, because our x and y coordinates have been swapped, I refer back to my original graph here, or the graph of the original function, and I'm going to swap everything that is x. For example, I've got an asymptote of x equals -1, so that translates to an asymptote of y equals -1. I have an intercept of 0, 0. You know, that's not going to change, but there is a swap of x and y values. And then I can sketch my graph, and it should look something like that. Now, the domain here is really important, and if I consider my domain from the graph, my domain is all real numbers. So therefore, when I come to write the inverse of f, I'm going to have the domain all real numbers, including all real numbers, dash x equaling ex minus 1. And this is the inverse of that function fx. All right. So when I come to exploring gx, and remember that g was given as -1 to infinity, all real numbers in between, gx equaling x squared plus 2x. I'll do a rough sketch of this, and I can see that it's a parabolic curve, but this domain is really important. Now, the more that you sketch quadratics, the more you're going to be able to recognize different characteristics of them. We can say here, when I have -1, I'm just going to take that off. Remember also that because we have a curve bracket here, what that translates to is an open circle. And we have -1, -1 as our point, and then a parabolic curve going up like so. All right, so we have our function here. This is going to be really important to be able to find what our inverse function is. We can notice here that this function is a 1-to-1 function, which is really important when we're going to try to sketch our inverse. So what we would do in a similar way to what we did with fx, we're going to swap x and y with our equation. So this equation is going to be written as x y squared plus 2x. Oh, sorry, let me change this. Plus 2y. Now that doesn't look, this function here doesn't look like it's easily resolved, okay? So there's some questions on how to do it, but those of you who are good with methods will realize that to be able to deal with this function, you're going to have to complete the square. So if I start to replicate this like so, and I'm going to complete the square by adding half of this all squared, then I minus the same value all squared, and what that gives me is x equals y plus 1 squared minus 1. And then this can be easily resolved for y, okay? X minus 1 equals y plus 1 all squared. We can square root both sides, and we can say that y equals x minus 1 minus 1. If I do a sketch of that graph, so this is the inverse of g, what we get is still -1, -1. Remember, x and y have been swapped, okay? Still going through 0, 0, but the nature of the curve, or the orientation of the curve, has changed. And we would also have a look at our domain here. Now our domain here is written as -1 to infinity. Okay, now that's different, and that's based on the range within this function, or the original function. So when we come to write g inverse, we would write it as -1 infinity, all real numbers in between, and we would say g inverse x equals square root x minus 1 minus 1. And this is correct.